My name is Srinidhi. I lead the tech at NeuroDiscovery. So today I'm going to touch upon some of the challenges that we faced as an early and young company in the space of neurology, working primarily with the US healthcare data. And some of the challenges, most of the challenges have been around gathering the data, as you all can imagine. Making the entire data pipeline HIPAA compliant is one of the major challenges with healthcare. I'm going to touch upon that, and along with that, we'll also spend some time understanding how we can utilize this data to improve the operational efficiency as well as the quality of patient care, and how we can use this data and the models that we have available to us right now without having to reinvent the wheel. So with that, let's get started. I'll quickly just let you know what we're doing with NeuroDiscovery AI. We are a pretty young company. We are a 1-year-old company. We got started in February of last year. I was the first person to join the team. I am the Vice President of Technology. We have around 30 to 40 people. What we are essentially trying to do is we're building the world's largest data set in neurology, and specifically a longitudinal data set in neurology. And one of the most interesting things about healthcare, to those of you who are interested in venturing into the space, or probably you guys have already noticed, I know some of you guys have experience in this space, is the data is multimodal and the data is vast. And there are a lot of hidden patterns out there for us to discover, right? So that is essentially the task that we are undertaking specifically with neurology. And when I say the data is multimodal, we're talking about structured data and all of the traditional data that we are used to working with, people coming in from finance or traditional academic backgrounds. But along with that, there are a lot of healthcare specific data sets as well, that modalities as well that we work with. Primarily imaging data. There is a specific format of imaging data. There's omics data, which is again the new buzz, and that's where like a lot of hidden patterns are waiting to be discovered. And towards this end, our goal is to essentially focus on 6 neurological disorders, as you see: multiple sclerosis, Parkinson's, Alzheimer's, frontotemporal dementia, and migraine, and eventually get to autism as well. But as of now, since we're not dealing with any child practitioners, we do not have the data set to work on autism. So there are 2 primary goals, or there are 2 biggest problems that I would say that exist for technologists to solve. The first and foremost is to improve the quality of care for patients. It is very it's ripe for disruption, especially, and considering the advancements in tech, I would say the 10x opportunity is right now. So to those of you probably who are looking to venture into the space to work in an early stage startup, or probably even start something of your own, unless and until you build a 10x solution for clinical practitioners, chances are your product or your solution is probably not going to be adopted. And right now is the right opportunity for you to build those 10x solutions. And also personally for us, since we're dealing with neurological disorders and longitudinal data, we also want to stop or reverse the progression of these disorders. And towards that goal, we have some ambitious targets for ourselves in terms of the size of the data, as well as what we want to achieve with that data. So I'm going to try and keep it brief and maybe keep it a little more interactive if some people have questions. So what I'm primarily going to focus on are the challenges that I've faced primarily with respect to healthcare data. So as some of the speakers might have talked before me, making the data compliant with HIPAA is one of the major challenges that most people dealing with healthcare data face. And that's again one of the things that we ourselves have faced. And what we essentially do is we partner with neurology practices, and we get the data directly from the source. We look into their tables, we de-identify the tables directly at the source, and we get both the structured and unstructured data. So I want to take some time to talk about the modalities of the data. So one of the things that we see with healthcare data is we have both structured and unstructured data. De-identification becomes a task. And when I say de-identification becomes a task, it's because when we talk about clinical notes, think of a clinical practitioner writing text on a piece of paper, and this text could contain any number of PHI elements, and PHI elements are essentially personal health information, or pieces of information that could directly identify a patient. And you cannot move this data, or you cannot process this data without removing this. So a lot of technical expertise is required, and a lot of technical workflows are required before we can even start using this data. For example, when we're dealing with PDFs, right, we have to do OCR. We get the pieces of text, and then we apply de-identification rules on these specific pieces of text to remove all of the PHI elements. And secondly, when we're talking about imaging data, I'm sure some of you already know. So we have pixel data, right? And if we have to remove pixel data again, that's again a separate task. So we deal with multiple modalities of data, and I would say the most of our, based on our experience, what we have seen is most of the underlying insights we are getting from the unstructured data. So when I say unstructured data, primarily clinical notes. That's where we find a lot more information about patients than what is recorded in tables, or what is recorded in the EHR, and also the imaging data. And we are also in talks with the leading institute in the US to gather some omics data as well. So we're also doing genomic sequencing for some of the patients with specific disorders that we are focusing on. So once we gather all of these, the multiple modalities of data, the idea is to essentially de-identify them and move the data onto our server, where we are essentially running all of the computationally heavy models to gather these insights. So one thing that we have seen is essentially there are different formats to export patient data, and what we know is a lot of these formats, for example, HL7 and FHIR, they do not work for us because of the solutions we are trying to build. And the solutions we are trying to build are specifically patient focused in terms of clinical trial matching. If there's any new drug that comes into the market in the US healthcare ecosystem, there are multiple clinical trials. Some of you might know already, but for those of you who are new to this process, there are a lot of operationally heavy workflows in terms of clinical trial recruitment. That is something that we want to disrupt with the data that we have. And to achieve this outcome, we essentially need a lot more data than what is supported by the current data export formats. So what we essentially do is we plug our de-identification tool to the raw tables. And to give you some context, the EHRs that are currently operational in the US, they're not standardized. The way the data is stored across multiple EHRs is not at all standardized. Some of the EHRs store data in 6,000 plus tables. We've seen some EHR store data in 8,000 tables with no data dictionary. And we have also seen EHRs store the data in 600 to 800 tables with complete data dictionary. So this is one of the biggest challenges, I would say, in dealing with healthcare data. The data itself is not very standardized. So what we essentially do is we create our own data. We've done our own data modeling exercise to identify the key pieces of data that we need for every patient to do the clinical trial matching. And at every healthcare practice, we have our own de-identification solution along with our own hardware deployed on-prem, which pulls the data from their own raw tables in case they have their own on-prem servers, or if they have a cloud-based solution, we also offer a solution, de-identification solution for that. We do the de-identification across all of the past 20, 25 years or whatever is the vintage of the data, and along with that, to do a data refresh and to do a change data capture, we also pull the data every 15 days. And the idea is to keep the data as fresh as possible without essentially leading to a loss of data in terms when it comes to dealing with multiple EHRs. As you know, like I told you, the EHRs, what we've seen is standardization of data is something is an unsolved problem across multiple EHRs, and that's pretty much the main problem that we are solving. And considering the opportunity at hand and the data that we've gathered, one of the things that I want to focus on is also what can be done to accelerate trial recruitment and discovery, right, with this data. So what we see is essentially, operationally speaking, we've also recently we were talking to one of the pharma companies where a new surgical trial that they were trying to recruit patients for, they spent the past 3 years trying to recruit patients, and that's a problem that we could solve in less than a week. And this is primarily because the data itself, as it exists right now, especially in neurology, it exists in silos, and there are multiple middlemen trying to broker this data across stakeholders. This is something that can be completely standardized with technology, right? And this is something, there's an entire value chain that can definitely benefit with the standardization of data. And that's pretty much what we are doing as well. So we have data spanning EHR and imaging. Omics is a very, very small part of our data set right now, but that's something that we are actively focusing on. So with the data that we have, one of the major challenge also becomes, how do you scan through millions of rows of structured and unstructured data, and how do you create a cohort of patients that match like inclusion-exclusion criteria for a clinical trial. So to give you some context, every clinical trial is published and the recruitment happens on the basis of like inclusion-exclusion criteria. Think of them as simple filters that need to be applied on patient data. This, although the problem seems simple, because of the lack of standardization of data, becomes a very, very challenging problem. And that's pretty much the major problem that we are solving. And one of the goals for NeuroDiscovery as well is to build a neurology-focused language model. And the reason for this is that right now what we're seeing is we do not have a lot of neurology. We do not have a lot of quality output that we're seeing even from medicine-focused language models. We've tried some of the leading benchmark leading embedding models and language models, but the nuances required to segregate, I would say, patients on very specific nuances specified in like inclusion-exclusion criteria, or like very specific language used by clinical practitioners and neurology. This is something that's not possible with the existing language models. And one of the reasons to also build this is to build a data interrogation tool or an AI copilot for clinical practitioners to assist with their operational workflow, and also to give insights based on the past medical history of the patient. Something that is a huge task, and also takes up a lot of time out of a clinical practitioner. And the second most requested, also, this is a slight tangent, but one of the requests that we have gotten from the providers is clinical documentation itself has been a major pain point for a lot of the practitioners, and plugging this data back into the EHR in a way that could be used for downstream analytics, that again is a big challenge. So one of the products that we are working on, although it's not a technically challenging solution, but operationally it will improve the outcome for a lot of providers, is a voice-based clinical documentation tool, right? A simple mobile app that the practitioners can use to simply record the clinical notes and feed that back into the EHR, and feed that back into a database that could potentially power a lot of downstream use cases. One of the things that I talked to you about was the data interrogation tool. So this is essentially a RAG-based app for those of you who are aware of RAG, it's what we essentially do is we deploy the LLM on top of a proprietary data set. Retrieval augmented generation is what it stands for. So what we essentially do is we take the patient data, we move the data first of all onto our platform, because the on-prem solutions do not offer the infrastructure needed to run these solutions. So once the data is on our server, what we essentially do is we chunk the data, we do the embedding, and we retrieve the data, re-rank it, and generate responses for our providers. And this is something that we are seeing actively being adopted by a lot of providers. The reason for it is simple. Right now, since a lot of documentation exists in these tables and accessible only through EHRs, the way for practitioners to interact with this data is through a software, and the software that is not very user friendly. But with a RAG-based app, what clinical practitioners now have is a chat-based interface to access the data and also ask very specific questions. Instead of looking through the software for some data, they can directly ask specific questions to our data interrogation tool and get those specific answers. We're also adding the ability, so one of the things that we've been recently working on is a model to essentially calculate the volume of cerebrospinal fluids just using brain MRI scans. And this is something that takes over 45 minutes to an hour through the conventional models that we have. And also, if you're talking about it doing it manually, then it requires time and effort by physical practitioners. So this is something that we can get done in less than 15 seconds using the model that we've built out. So right now our focus is also to integrate that with the data interrogation tool. So essentially, the opportunities that we see with the data that we have and the amount of disruption that can happen is immense. Along with that, we also have a couple of other tools that we're building. First is the cohort builder. The underlying tech for this is not very fancy, but the solution that we're able to build with this is, I would say, 10x better than what the current workflow allows, right? So to give you some context, the stack that we use is we use an Elasticsearch server. All of the data that we have, all of the text data, structured and unstructured data, is indexed on Elasticsearch. The main piece of tech that we had to build out is a text to DSL, right? So a simple inclusion exclusion criteria is mentioned, is passed as an input, and using the text based input, we convert that into a DSL query which runs on our server. So essentially, using this text to DSL converter, we're able to build a 10x solution. So this is, I would say, one of the biggest signs of what is the level and the quality of outcome you can achieve with like simple solutions. And lastly, we also have we're also working on analytical tools. So MIPS reporting is something that helps providers with Medicare and Medicaid based like funding. So that's achieving certain outcomes based on MIPS measures also adds a lot of value in their operational workflow, brings in a lot of revenue. So this is again something new that we can unlock with the specific data that we are gathering. So yeah, these are some of the use cases, downstream use cases of the healthcare data that we are seeing. That's primarily it. Thank you, guys.